Hi, good evening. My name is Balaji. Welcome to this interesting webinar on growing importance of service reliability and the role of AI or AI ops in service reliability. With me, I have three eminent speakers. Let me introduce one by one. I have the privilege of introducing Mr. Sriranga Mule. Sriranga Mule is a Senior Executive Vice President and Chief Technology Officer of NTT NetMagic. He is in charge of improving existing technology service offerings, identifying and building new services based on next generation technologies, and hopefully that's where AI interests him. He heads a 50 plus member team across India and is the chief architect of companies' cloud services platform, creating public cloud architecture for maximum efficiency and minimal cost of operations. Currently involved in enhancing the features of the NTT NetMagic cloud services, building network services and other value-added services with end-to-end automation and service lifecycle management. His core strengths lie in systems engineering and has expertise in infrastructure designing and commercialization of new technologies. While Sriranga is passionate about retro music of 70s and 80s, especially those of R.D. Burman, he's also a keen cricket and soccer enthusiast. I have known Mr. Mule recent past. His passion for technology is also extremely high. Welcome, Mr. Mule, to this webinar. Would like to introduce Professor Nandan Sudarshanam. He is very familiar to people at GAVS. Nandan Sudarshanam is a faculty member in the Department of Management Studies and a core member of the Robert Bosch Center of Data Science and Artificial Intelligence at IIT Madras. He earned his PhD from the Engineering Systems Division at MIT, following which he worked as a quantitative researcher for 5 years at high-frequency algorithmic trading firm in New York. His research and work experience focuses on applications of experimentation, machine learning, and more importantly, abstraction of data to models and algorithms. He's been an advisor to GAVS and has been helping us enrich our AIOps platform, the Zero Incident Framework. Last but not the least, let me introduce you to my dear colleague, Chandra. Chandra heads the IT team at GAVS, has about 25 plus years of rich experience in IT service infrastructure management, design and development of enterprise applications, and incubation of new products. Some of the recent product launches from GAVS with the Zero Incident Framework, CDesk, Xeris have been his initiative. Always thinks ahead and has implementation of disk-based backup using SAN replication as in one of his previous organizations as early as 2005. That's proof to his visionary skills. Welcome, Chandra, to this important webinar on service reliability and role of AIOps. Thank you all for taking the time to participate in this webinar. Service reliability, I'm sure people are all trying to figure out the myth about it. People talk of service assurance, service reliability engineering. A lot of terms are there, but we'll have the eminent experts talk through that. And more importantly, the advent of AI and ML, how is the AI ops platforms or initiatives helping in service reliability, and how service reliability is becoming important. Towards that, I would like to pull up the first poll question, which is service reliability gaining importance, or is it still operational efficiency and cost of operations? Please select one of the options, the audience of this call. Service reliability is the first option, improvement in operational efficiency, and third one is lower cost of operations. And I'm sure people have a divergent view of this, but would like to hear from you. Service reliability is actually gaining a lot of importance from the customers I speak to often, and also the marketplace where there are a lot of articles being written, but would love to hear your views. We'll close the poll question right now, and we'll see what people have responded to. As expected, service reliability has taken the win here. 63% have said service reliability is gaining importance. Operational efficiency and lower cost of operations comes to second and third. But it's very important to understand what exactly does service reliability mean. So towards that, Mr. Mule, would like to start with you, if you don't mind. What do you see and how do you see the importance of service reliability? People talk of service assurance, people talk of observability. As a practitioner, how do you see this as transformative needs of the organization? Can you please elaborate to our audience your views on this, please? Mr. Muller, we're not able to hear you.
Good. Can you hear me now?
Yes, yes, please go ahead.
Okay, great. So obviously, today, if you look at it, there's been a change in the kind of delivery models, in terms of what you deliver to your customer as a service. Of course, while the other parts of your question were definitely relevant in terms of operational efficiency and the cost of the rolling out of the service. While all those are important, but I think what's more important is what is the quality of the service that you provide to your customers, how reliable is the service, and while doing that, how much how much of in-depth information do you get about the rollout of the service, so that where are things lacking, where are things that need an improvement. Because what you deploy today on day zero is not that remains for the lifetime. There's going to be changes in the application. There are going to be changes in the customer requirements. There are going to be changes that you keep doing as a part of the innovation and bring in more and more capabilities and features. Now, of course, each of them have their own repercussions in terms of how it impacts the underlying infrastructure and the performance of the application. And I think what's important is, at the end of the day, for me, it's a dual level of service reliability that we need to maintain. One is towards my customer, my customer, I would say, direct customer for whom we provide the services. At the same time, ensuring that their end customers also see the service as completely compliant in terms of the expectations, in terms of SLAs and all that. And I think you should always be performing beyond the SLAs, and you should be just hovering around the SLAs that you commit, because that's where the actual service reliability really makes a lot of sense. And rather, I would say that that is where you would have put in the actual efforts of understanding the whole thing in depth, and put in a lot of efforts to improve the overall quality of the service, and the reliability of the service. So I think service reliability is very important. And I think today, you take any, I mean, while we say that some of the businesses don't run online, but then there is still a lot of touch towards the online processes. Either they use it internally or partially with their partners, or maybe even with their end customers. And everywhere, I think it's very important that you have to meet the expectations, or rather exceed the expectations. I would say, not just meet the expectations. You have to exceed your expectations, your customers' expectations. So I think that's very important, and I think we cannot just ignore it. And rather, I would say that's the most I mean, that's the area to be able to focus upon and improve. This is what my opinion on this is.
Nice, nice. Thanks, Mulay. This is good. As an extension and as another practitioner, Chandra, coming to you, what trends do you really see in service reliability and in operations management? Are you looking at these two disparate? Are you looking at these integrated? And how is it evolving in the minds of the customers we work with? What is your view, Chandra?
Yes, thanks, Balaji, and thanks, Mulay, for setting it. And when you said the quality of service, I go back to the days when we applied the quality of service only in the voice network and not in the data network. But actually, that itself is a good trend that we are talking about the quality of service and reliability in everything that we do. Before I get into the trends that is shown on the screen, I just want to clarify two things, because this question keeps coming. When we say SRE, is it a site reliability engineering as Google propagates that, or is it service reliability engineering, which we, the service providers, tend to believe that? But actually, it is service reliability engineering. I want to clarify that, because whatever I'm going to speak about the trends or the roadmap or how AIOps is going to help, it's largely about service reliability engineering, because the site consists of many services and each service needs to be reliable. So when you apply service reliability engineering on one service or more services or all the services that are running in a site, it actually becomes a site reliability engineering. That is one thing. Second thing, again, there is a bit of confusion whether SRE is as same as DevOps or different, or there is an overlap. There is an overlap between DevOps and SRE, but the common objective for both of them is same. That make sure that whatever you want to deploy it seamlessly, and whatever you deploy, let it run without any interruption. That's the objective of SRE also. So with that, what we are seeing in the market, More and more, we have been hearing the observability. So what is becoming is intelligent monitoring. Gone are the days when you do the stale monitoring or the superficial monitoring. Now, what we want is the intelligent monitoring. The monitoring tools are not just expected to provide just an alert, but they have to provide with the context. The monitoring tools are not supposed to send alerts that are not to be actioned upon. One of the key requirement of SRE model is that if at all a system is generating an alert, that alert should be actionable. To that extent, an intelligence has to be built in at the generation of alerts itself. That is one trend that is happening, which actually what it means is that a lot of validation checking is done at the source. The second one is automation. Again, this is driven by the continuous uninterrupted operations. And if at all any interruption happens, how soon we can quickly resolve that. And typically, a machine tends to resolve a problem, of course, if the solution is known, faster than a human. So how can we automate more and more? And how can we let the machine provide the resolutions more and more and reduce the intervention by the human? So the automation is also picking up as another trend. Again, these are all intelligent automation, not just the traditional vanilla automation. The third one is, of course, we talked about that is one of the webinar earlier, auto detect and auto correct. Let the system automatically detect what's going wrong, and based on the knowledge base and other historic resolutions provided, let it pick up the right resolution and auto correct it without actually letting the system go down and the machine taking over and resolving. This is a little one step ahead of the intelligent automation, that before the incident happens, the automation has to happen. That's the third trend that we are seeing. Then finally, not finally, but one before that is the user experience. Ultimately, we do all these things, intelligent monitoring, automation, correction, everything, to make sure that the end users who are using these services are happy about it. So what is happy? What is unhappy? As a user, I must be getting the same kind of response whenever I access it, irrespective of the day, time, week. I can't compromise myself. Monday morning, there is a load, so let me have a poor experience. Nothing like that. As a user, as every user, for every transaction they do on the services, they should be getting consistent response. For that, there are a lot of instrumentation techniques are being applied. So more and more tools are being deployed to find out actual time that the user takes for every transaction. And in case if it is not within the limits, what needs to be done on the application, all these are done proactively, not reactively. And the remedial actions are taken place so that the user gets consistent response. And fifth one is the progressive rollout. And we have been hearing that there are organizations that are doing the rollouts every 10 seconds, every 30 seconds, every 1 minute. As a developer, as a software developer, always want to make as many releases as possible because he wants to improve every time. And if every release is going to take time, then the number of releases would go down. That means the number of new features that we would provide as part of the services will also be at a very less speed. So how can we actually release more without creating an interruption? So this is where the new trend is emerging, the progressive rollout, where there is no downtime at all for rolling out any change. You actually take one small portion, roll out, and then test it, and intelligently find out the problems, correct it, and either roll back or keep moving ahead. So the trend is the user are actually getting the new features without actually any downtime. These are the 5 key trends that are happening in the SRE space, Balaji.
Thanks, Chandra. That's well put. The difference between service reliability engineering and site reliability, and how some of these 5 points adds up to a service reliability. With that said, and as a creative person, Professor Nandan, I'll come to you now. How do you really see all this shaping with the advent of AI and ML? With AI and ML doing a lot of heavy lifting in operations, how does it actually help service reliability? Some light on how does it do and what does it do would help from your perspective as a creative person and a person who is engrossed in solving some of the business problems using AI and ML, Professor?
Sure, Balaji. Um, so I think it's very interesting that this question got asked right after Chandra's fairly elaborate breakdown of all the things that one seeks to achieve, right? And many of the goals that AI and ML seek to address are very much the same bullet points. So automation, user experience, uptime, right? These are the same tenets. So in a sense, one could argue that what has been the drive and need for a long time is still the drive and need now. But what AI and ML are doing is, more about the scale and how effective they are at doing what they're doing. See, because again, for the same purpose, whether it's user experience or let's just say automation, right? That metric has always been around. And how did one achieve automation in the past? Might have been to kind of think about the problem and come up with some rules, right? Like, so you come up with a rule that says every time, instead of querying a human being, let's speak to the human being, see what they would do. Let's try to automate that. Let's try to write a piece of code that will do the same job. And so, or hey, I'm getting too many false alerts. Okay, why is that happening? Maybe I can write a small rule that says these kind of alerts, stop it. Now, all of that is automation and all of that is happening still a lot. But if the question specifically is how is AI and ML coming into play, right? We're moving away from, or I would not say away from, I would say we are moving beyond just the rule-based approaches, because you become heavily reliant on a human being to tell you what a good rule is. And don't get me wrong, human beings are amazing. We are amazing at intuiting what the problem is in a very noisy environment. But when the problems are reasonably simple, there is a point at which the complexity of the system becomes so horrific and the scale grows so much that we are not able to catch on to some of the interconnectedness. So some of the tools that was working really well for us, which is this rule generated way of doing automation, right? Which is to say, if these kinds of alerts are useless, let's change that, or let's try to trap them. Does not work when you have so many machines that are talking to each other, so many applications that are talking to each other. The degree of interactions and interconnectedness has gone so much. So the approach of AI and ML is to say, give me an objective and I will sift through the data and tell you what needs to be done to achieve the automation. So we are still using human beings, right? In some sense, we are still using them to know what variables are important, what variables are not, what is the intuition behind. But while people are very good at telling you something is wrong and something is right, they don't always know why it is wrong or why it is right. So AI and ML kind of take that guesswork away and say, you don't come up with the rule. You tell me if something is working. You tell me if you're happy. Can I observe if the user experience is good? Do I see you access it the same way as before? So a combination of observing human behavior and querying human beings are taken to the next level, where we don't say you generate the rules. AI and ML will take care of doing this whole thing in a data-centric way. And thereby it is able to scale. It's capable of seeing all the kind of interconnectedness between multiple machines, multiple applications, multiple nuances that a human being might have never been able to put the two and two together about.
No, thank you, Professor. And I know that we will have further elaborations of some of the details, but sometimes all these jargons become a little fuzzy for people. And while I think AI/ML is well suited to work through a lot of patterns, identify a lot of patterns, irrespective whether they're good or bad, and then figure out how to infer from there or provide some insights. I think it's still trying to find out how it is actually applicable the real world of service reliability and operations. With that as a backdrop, Mr. Mulay, how do you see in all these digital transformation, which is the buzzword today, and especially in your day-to-day operations where you're serving so many customers, how do you see service reliability promoting end-user experience and service reliability being the fulcrum of providing that experience to the end user? What is your view and experience of having such a thing in the middle of your end customers?
See, I think end of the day, we have to understand one thing, that customer delight is the ultimate thing, to be looked at. When if you're doing a good job, doesn't mean that, unless you're doing it in the right sense and the right perspective, where the customer sees it, something, which is helping them, meet and or rather exceed their expectations from their end customers. I think that's very important. And for that, I think whatever I think, Professor said and Chandra said, I think it's imperative that we have to break the shackles of the traditional things to a certain extent and come out of that and actually have to get into a different mode of working, because it's impossible. I mean, the kind of spread of infrastructure, the spread of applications, the spread of different platforms that are in use, and if and while there could be people who would be kind of say who would know the platform in depth, it's fine. But then can you replicate it 100% for all the environments, for all the customer environments, at the same time? That's one. And secondly, I think if I look at the overall state of the operations from a day two kind of operations, I think I would always put them into two buckets. One is something which you do on a proactive basis, and one is something that you do on a reactive basis. And I think more importance goes to what you do on a proactive basis to make sure that your reactive incidents actually drop down and come down. Ideally, I would like to see zero, but I'm pretty sure it's very difficult to reach that number of zero, because there could be certain things beyond completely your control that can cause some incidents. Only thing is, can I reduce the impact during that time, and how will the tool help me if at all I get into a reactive incident? But more stress would be on what can I do proactively. Now, when we talk about the proactive part, some part would be to do the regular stuff of maybe patching the servers, getting the compliance part right, make sure that there are no security issues. I mean, a whole lot of stuff, right? I mean, managing the capacity of the infrastructure, all that is fine. But how do I achieve it? I cannot be just relying on taking graphs and data from multiple monitoring tools and multiple places, and then start looking at all that and correlate and say, hey, look, for this application, if there are say 100 servers, I cannot be putting data, collating together all this 100 server data, then analyze and then come to a capacity management. That's not possible. Secondly, if I were to just treat like, okay, let me do one thing, which are the most vulnerable ones in terms of the number of alerts that I've received in the infrastructure. That's what people do, right? They take top 20 or top 50 devices and say, how many incidents have come on that particular device, and then for which services. I mean, there are a whole lot of statistics that people kind of generate data. They generate and then try to find out the bottlenecks or the areas of improvement. But I think that's very difficult. I mean, to do that, rather there has to be something which is like more predictive in nature, and which is happening at runtime, as and when something is getting monitored, something is happening. There has to be a way to keep predicting things, so that we know that after a given a time for as a gestation time for the data to mature, I think the prediction engine has to start giving out some results and predicting a lot of things, which I think will reduce the mundane efforts that people have to put in doing that analysis. I think my take is today, without, and I'm sure most of the people on the panel as well as the audience will realize and kind of agree with me, is be it a proactive support or a reactive support activity that you're doing. I think today 80% of time is being spent on collecting the data from various sources, 80 to 90%. And just that balance 10 or 15 or 20% whatever time is actually spent on analysis, right? And even that 10 to 15% is because now you have so many sources of data, you have to do a lot of correlation there and then come to some analysis, which is a sheer waste of time, right? Uh, 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 I would rather have spent that 80% time on something more productive. So all these things are very important. AI in the operations, is really something very important, which will obviously lead to the service reliability or the quality of the service that you provide and all that. Because end of the day, what you are looking at is to be able to get the information much faster, and I would say more qualified and classified information that you get by kind of removing a lot of other the unwanted things have to go out. You have to be more precise in getting that information. It may be 100% precise, it may be 80% precise, it may be 70% precise. That depends upon the maturity of the data and so many other things that come into play. And over a period of time, it becomes more and more matured. But even at 70% or 80% maturity is very important, because that can save maybe 80% of my time, and I become more productive. And the most important thing is, if that happens on the predictive side, I get a lot of time to make sure that I put the corrections and the changes in place so that I don't get into any incidents to the extent possible, and I avoid a lot of rush of blood and so many things that happen when we actually get into an incident. So I think it's very important, and I think what Chandra said and what Professor also said. I think if you look at all the points that Chandra mentioned about the various things, I think that's where the need is. Because I think if I look at an isolation, maybe the monitoring systems, I'm sure every customer or every deployment has some monitoring system in place, no doubt about it. But I think what is important is, am I getting some intelligent data out of it, which will help me take some decisions? And I'm a firm believer of the fact as to, if I get an alert, then definitely it has to be actionable. I mean, it can't be something that, oh, it came and went, fair enough. But then what am I supposed to do with it? Is there something actionable? Or is it that that's going to happen at a particular day and time? Should I keep it at the back? Should I still, figure it out as to, is that really important for me? Is that going to make a difference to me? Or is it something that's well within the overall acceptability of the platform in terms of its performance and in terms of what it is supposed to perform? Now, I could have a few servers go down, no problem. Now, is that so important to me? What is important to me is maybe my business KPIs, which is again related to some of the overall performance matrix of the entire system. So, am I worried about those servers going down or some services going down? Yes, I am. But then, is my business KPIs getting impacted? No, then that's fine. That means I've built enough resiliency into my systems. I'm able to handle those kind of I'm able to handle those kind of issues with the infrastructure. And I think we should assume the fact that there are going to be problems with the infrastructure coming up sometime or the other. I mean, nothing is going to work as smoothly as it is forever, right? There would be some of the other issues come up. So I think while we are talking about this, in terms of the ability of the systems to give more classified data, have more built put in the AI and the other aspects of it. But I think we also need to look at the underlying architecture and the design of the application itself. That's very important. And how resilient is that from a design perspective, and how resilient is it from an infrastructure standpoint, as to how much have we really put in an effort to really build that and deploy it. So I think a lot of things matter, and I think that is exactly what we kind of end up doing each time. Either we do it right from the start, where we help into the design phase, or it could be once we get into the management of that infrastructure, we kind of get into all these activities. Yeah.
Okay, this is very good, PM, Mr. Mulay. Thank you so much for such elaboration. Now, Chandra, back to you again. You're the progressive creative guy here. So where have you seen implementation of such principles, right? I mean, examples where you've seen AIOps helping customers in service reliability, or maybe like the whole question came, improving efficiencies, maybe like what you suggested, improving end user experience. What examples can you share with the audience for them to relate to how AIOps is actually helping in some of these key evolving constructs?
Yes, thanks, Balaji. And again, thanks to Mulay for setting the stage for my response. If we are talking about proactive detection and prediction, we can't achieve these two without AIOps, or artificial intelligence. Just a human or the traditional automation will not help us in detecting things proactively and predicting things well in advance so that we eliminate the incidents and let the services run uninterrupted. So there are definitely AI has to play a role in the IT operations, and it has to be completely different. Let me say 4 or 5 examples that we have deployed and we are seeing that emerging. One is this correlation of various events and alerts. We talked about that the need for SRE is to generate alerts only when it is actionable. But today, that is not the case. With the proliferation of tools across multiple layers, the systems are generating too many alerts and events, and there is a need to correlate them based on the problem and based on the relationship that they have with the devices to each other, and identify the false positive and identify the actionable alert. Now, one way of doing that is using the relations, which is not of AI. Not only that it is not AI, but the accuracy of such correlations are not as good as what an AI algorithm-based correlation would do that, because there are some issues and incidents that are happening which are beyond just the relationship of the devices. So that is where the pattern recognition comes handy. Pattern recognition uses a unique algorithm, and that sees through all the events and logs that are coming into the system based on the time series, based on the frequency, and based on the pattern and others. It actually identifies the patterns, and the patterns that keep happening, patterns that keep happening in sequence, and that provides an insight about the correlation. This is very, very important, and we have found this being very, very successful and doing better than the traditional relationship-based correlation. That is one thing. And the next one is, we also talked about prediction. Again, prediction is going through the historic data and figure out what's going to happen, say in the next 6 hours to come or 6 days to come, depending upon the kind of data and the volume of data that we pump in. The system should be able to predict, and the AIOps actually helping that. What it means to the IT operations is that we come to know of what's going to happen for a particular service or an application or a network infrastructure well in advance, and it gives us sufficient time to take action on that and thereby eliminate the alert and the incident at all. That's the second thing that will happen. Anita, you can keep moving the slides. The third one, Professor talked about that, is the reinforcement learning, where today the monitoring tools generate alerts, and there is a rule that says what is the threshold. Once it crosses the threshold, then automation comes and provides the remediation, either the automation or the level 2 or level 3 engineer. But the AIOps is actually playing a role there, that instead of getting the alert all the way passing through till the automation, why don't we move everything at the source itself? In the sense, the AIOps agent, or we call it a reinforcement learning agent, runs in each source that generates alerts or whatever it does. And then it knows what is the right value. Again, we don't need to set any fixed threshold. It knows by continuously learning the system what's the right value. And the moment it actually breaches that value, it actually kicks the automation and makes sure that the system is running at the right level. So there is no alert here, and there is no trigger for automation. Everything is done at the source. So this is the third example of how we can use the reinforcement learning, which is one of the key AIOps, and make sure that we actually bring in the zero human touch. That's the third one. And can you go to the next slide, Anita? Fourth one is self-learning bots. Again, alerts getting generated, and we normally see it and take action. Either you do some initial triaging, and then we take action, and then either create a ticket or close. All this action, for different actions we do for different alerts. Now, there are self-learning bots as part of this AIOps system, and they actually watch what a human does. And it learns, and then after a certain time, when you activate these self-learning bots, they actually start doing the jobs on their own. For example, whenever an alert comes, high priority alert comes, someone has to acknowledge. This acknowledgement can be done by the same. After acknowledging, depending upon the severity, depending upon the device, it does the few triaging. Again, the self-learning bot can do that. And if nothing happens, a ticket needs to be created. The bot can do that. By the time, before someone resolves that, if the situation comes back to normal, you need to close the ticket. This bot does that. So everything, like what a typical human does, the self-learning bots keeps doing that. This is what we saw in the first one. More and more, the machine should do the actions and less by the humans. This is the fourth one. Is there anything, one more, Anita? The last one is the user experience. We saw how important it is. So one of the example is to find out how much time the two nodes that carries the transaction takes place. Continuously monitor that and plot it. And whenever there is a deviation, there is an anomaly from what the historic mean from the current one, alert that. That means there is some problem between these nodes. You can see in the center mapping, there is the transaction time increased to 5 seconds, whereas the normal one is 3 seconds. That means there is something problem from the user to the node. It immediately alerts. Now, the user is not experiencing a big problem. It just indicates that there is going to be some problem. It immediately flashes that and bring in either the automation platform or the human engineers to start working on that and remediate that before that 5 seconds becoming 10 seconds or 30 seconds, and one user getting affected from 10 or 100 or thousands. So this is what we call user experience, and this is done through the network angiogram because it actually tells where there is a data choke. These are few examples, Balaji, that AIOps is actually playing a role in the service reliability.
No, thank you, Chandra. This is very insightful. Really helps in understanding how AI is actually being leveraged in service reliability, improving efficiencies, improving end user experience, and many of those factors which you talked earlier, the 5 factors which you talked earlier. With all said this, Professor, interestingly, there's a lot happening in this space, right, in the AIOps space. Besides the algorithms, besides people talking of machine learning algorithms, what are some futuristic things people are looking for, both in AIOps space and AI in general? Something from your experience, something you've been interacting with various industry experts. What's the trend like? What's happening there?
So I think that's an interesting question. I think on multiple fronts we're seeing different things, Balaji, to be honest. So it's hard to kind of bin AI as one. So I'll speak a little bit more broadly about some of the futuristic things that I see or I foresee in AI in general and how it applies to AIOps. So from AI's perspective, you have these problems that when compared to human beings should be very trivial, but AI finds it very challenging. We've all seen these memes and jokes about that, right? Like, so simple things like object identification or language generation, which you would think a child finds very easy to do, and yet here AI is really struggling with this. So one of the things that we're seeing, and you contrast that to something like chess, right, where AI is just blown human beings out of the water, right? So there are some things that AI finds challenging, again, keeping a human as a benchmark. And there are some things that seem almost trivial. And a lot of that has to do with whether the data is kind of structured or unstructured. So, in answering your question, I would say there is, in terms of futuristic or in terms of where is there a lot of effort? As far as I see it, on some of these really hard challenges, there's a lot of effort, right? So something like autonomous driving or something is a real confluence of a whole bunch of really hard tasks for AI, right? So you have to identify objects, you need to understand the human being, you need to understand a whole bunch of parameters. So I definitely think that a drive in that direction is leading us to look at this newly coined term called artificial general intelligence. AGI is one of the hottest topics that's there in AI right now, where the hypothesis is, instead of looking at this as individual tasks that need to be carried out, can I have a certain meta level of learning, right, which helps me kind of replace the human being in all of their richness and variety, rather than looking at it as taking a task and fulfilling just that task, right? So there's a lot of push in that direction. So it wouldn't be too surprising if you saw a layer of AI, which is no longer just a tool which performs a simple task, but is in general this almost feels like this living, breathing agent that is taking care of your infrastructure. So it's not doing only prediction, it's not doing only correlation, it's doing prediction in the context of something else happening somewhere else. So there's a lot more of interconnectedness. So instead of doing something like ticket time resolution or escalation as small bite-sized problems, this taking it to the general level, right? What would a human being do when we all put on our dresses and go into work? We are not compartmentalizing ourselves so much to solve only one task. We look at the agency and the organization and the IT infrastructure in a much broader sense. So can AI get to that level where it's not solving a single problem? So that's one direction that's definitely pushing off. The other is highly related to what Chandra was talking about.
While you are exchanging and sharing your views, I'm sorry to interrupt. I request the audience to post questions to the panelists so that I can relay to them. So audience, can I request you to post some questions on the question or chat window, and we'll be happy to take them to our panelists. I didn't want to lose that opportunity, Professor, with about 20 minutes to go. Go ahead, Professor, sorry.
Not at all. I was just saying that, look, there is also this other, area. So, I mean, even if you take the simple, what we call as simple problems, they're not simple problems at all, but we call them simple because we're able to beat human beings, right? When AI is able to beat human beings, even in those cases where the data is extremely structured. So some examples of it might be, ticket time resolution. Some amount of it is prediction in terms of very structured networks, very structured data. You predict what is going to fail next. You predict time to repair and things like that. Even there I think what we're going to see is a lot more of moving beyond prediction. So we've taken automation all the way from rule based to data centric, but so what? All of that led you to make a prediction. Where did that prediction leave you? Oh, the prediction left me with a human being taking a call on something to do. The prediction helped me. The prediction helped an engineer make a decision. Well, can I automate that? So let's not stop at the insight generation level. Let's not stop at the prediction level. Let's go ahead and enable the agent to take the corrective action as well based on the data. Now that comes, and that is the cornerstone of reinforcement learning. That has been the cornerstone of the thesis of many products and ideas we've had at GABS. But for the audience to fully appreciate that, that comes with a lot of challenges. It comes with a challenge that I don't think I'll have the time to fully talk about, but it comes with the challenge of how do you know how something will work if you have not tried it? How do you know how something will happen if I don't run a particular job at a batch job at a certain time, if I don't do some kind of remedial measure, and so on? So as opposed to what is traditionally seen as the passive consumption of data for making prediction, which is itself a big paradigm shift from the rule-based, we're talking about the next wave, which is how do I start controlling? So rather than thinking of it as a learning problem, think of it as a controlling problem. To control, you need to learn. That's a given. But my objective function is no longer to come up with the right learning or the right prediction. My objective function is now to autonomously and effectively control the system so that it gets the desired results. And for that, I might go and ask for data, process data, learn from data, predict on data, and so on. But those become the intermediate variables in some sense.
Right. Oh, thanks, Professor. This has been interesting. Audience, I'll request you to post your questions to the panel. I will be very happy to take your questions. While we do that, we actually have a poll question ourselves. The next poll question is AIOps becoming mainstream in operations and end user experience? I repeat, is AIOps becoming mainstream in operations and end user experience? The choices are yes, no, and not yet. It'll be interesting how AI is actually becoming or not becoming mainstream. I would be happy to hear the choice of the poll and the choices coming out of the audience poll. We'll close the poll now, and we'll wait for the answer. And the answer is it's becoming mainstream, is what majority of the people are now saying. 86% voted to say AIOps is becoming mainstream, and the rest are saying not yet. Nobody's of course said no, but it's not yet. So interesting that the audience is also aligned to some of the things which are evolving here. I'll take the next few minutes quickly, 2 minutes each. Mr. Mulay, you have been in this industry for quite some time. You really see the evolution of AI, evolution of automation. Where do you really see the service reliability and operations management heading? What could be the future look like, especially with the advent of serverless computing, cloud in a big way? Where did you anticipate, and how do you anticipate AI will change, and what could those be? If you can briefly touch on those, please.
Yeah, sure. I think before I get there, I think just wanted to take a minute on whatever I heard from the panelists, especially from Professor and all. I think in a practical, and I just allow me for that 1 minute because I think it's very important, because I've been coming from the industry where we actually practice it. I think I can resonate my views with a lot of my fellow members who are a part of the audience. I think we have to be very careful, and while the control-based thing is very important, and that's the future where I think things will go to. But I think at the same time, we have to be very careful in the practical sense of things as to where do you lose the control or allowed to lose the control, and where do you keep it to you? Because many a times, you don't want to create a problem while fixing another problem. I'm not pessimistic about things, but I think we have to be very careful as an end user, or as an end user of the system. I would say I have to be very careful. Where do I keep the control with me, and where do I start giving the control back to the system to take a corrective action? And I think there are ways to do that, because whatever we do, I think it even in in our own lives, like you have a lot of, you say you have a high fever, and you go to a doctor. The doctor may not be able to tell you whether you are with, you have a typhoid or malaria or a dengue, unless you do some particular test. So it actually applies it here, specifically. Now, how much can that test be automated based on certain inputs that you get will really help people to decide where to start giving the control back to the system. So I think today the best way to start using the system is at least make sure that the amount of time that you spend in doing certain things, using a part of automation. I mean, what Professor said, the AG intelligence, right? At least use that. One is, or just use the pure intelligence. I mean, forget about the A for a moment. At least use the pure intelligence within the system itself to automate a few things. That's where you can save some time, and that can be reducing your response times to your customers. And use the AI part to become more and more predictable, right, over a period of time, because it all depends upon how repetitive those incidents are. Not everything may be so repetitive in nature. So it will take some time for the system to mature, but at least can we come to a level where you put a manual control somewhere saying that, okay, I'm seeing these predictions. Can I go back and check quickly? Yeah, this is what is happening. And then maybe invoke the actual, corrective action, so that would still be faster than you actually going and doing things, right? So I think there are ways to handle it, and with all due respect to the artificial intelligence and the algorithms and everything in place, but there would still be certain exceptions, and I think it's better that we tune the system for those exceptions much faster, so that our predictability and the overall usability becomes much more I mean, it actually starts helping the cause for which we put all the systems in place. And this is tying down with what I see how forward this goes to. I think if I look at it as a service provider, I think it's very important for us to kind of get these systems in place and play around with the systems, config, do whatever configurational changes are required, whatever fine tuning is required over a period of time, and make it more effective. Because to me, I think customer delight doesn't just end with being able to meet their SLAs. The customer delight also is by reducing the cost of my operations and reduce the cost that I put on my customer. I mean, you can imagine if there was a project where there's a 200 or 300 people working on that project for the kind of size of thing, right? Or maybe even 50 or 100 people. Now, their operations is going to grow over a period of time for the customer themselves. So do I keep scaling people? Maybe, yeah, I can do that. But then is that the cost expectations? Will that bring a customer delight? No. So if I look at the practical side of it, the customer delight comes from both sides. That I reduce my cost to the customer periodically. I mean, over a period of time, we kind of show a reduction, and at the same time reduce what would you call the mean time to repair, the MTTR, increase the MTBF or make it zero to the extent possible, and reduce the downtimes, because every downtime costs a lot of dollars for the customers depending upon the nature of the business, right? And you don't know, right? While I mean, what kind of impact can that 15 minutes really cause you, of a 20 minutes of a downtime that can cause you? Nobody knows, because you might have lost a lot of opportunities which you would not even thought of at that point in time. So definitely nobody wants to see unscheduled downtime, I would say. So I think AI and the ML and the overall, the efforts that are going on in the direction is really going to play a major role. And that is where I think the scalability of rolling out the services and the predictability of rolling out our services and making them more repeatable, which is very important. And I think that is something we just cannot afford to lose a sight of. And I think this will be a major factor that I see in the coming few years. And I think next 4 or 5 years, I'm sure a lot of things, a lot of these algorithms and a lot of these products will become more and more matured, with a lot of other use cases coming in, and a lot of data that will get into these systems, which will help them mature. And I think it'll become more and more predictable and repeatable, which will really help running a smooth operations, is what I think.
No, thanks, Mr. Thanks for the clarification. I think it was important to put the right caveat to people's assumptions about what AI and ML can do. On the same lines, there is actually a question from an audience specifically directed towards you, asking, what do you see as challenges in an enterprise IT operations from your customers? Some top couple of challenges which you keep hearing in running operations from your enterprise customers.
I think the top two, if I say, is obviously the first thing is to keep their operations running 24/7 by 365 without any impact, right? And while doing that, of course, there are multiple factors, right? I mean, there are changes in the application that are happening. There'll be a change in the nature of usage of the application that keeps happening. There could be some amount of promotion going on somewhere, which is going to kind of attract more traffic than the regular one. So there's so many changes that keep happening on a day-to-day basis, and some things would be periodic in nature, which can still be predicted and you could do something, but certain things are completely unpredictable, right? So keeping that in mind, with all those uncertainties that are going to come up, we have to be prepared for the running the operations on 24/7 without causing any downtime, which means a lot. And I think these kind of incidents to be reduced or to be minimized, I think that's a big thing. And that is where these kind of tools will really come in handy. The second thing is, of course, as I said, be it enterprise or be it any customer, I think the cost at which I provide these services is equally important. So I think the AIOps actually helps us, to tie down both the motives, together, to actually give a better customer delight. And these are two important things, because I may be doing the best of the job, but if I'm not able to match it at the customer's expectation in terms of price, however good a technology may be, it's of no use. I'm not going to be able to serve the customer, because he won't be my customer at all. So I think we have to look at both the sides. One side, the technology, the overall roadmap and progress and features and capability. The second side, I think you still have to keep an eye on what the customer can really afford. I mean, I don't have no offense to the affordability from a customer standpoint, but I think we have to look at the practical side as to, will somebody pay me so much for whatever I'm doing, and will I be able to really show that and make a big difference with whatever I'm doing as to where they stand today and how will I improve it over a period of time. So I think that's a big challenge, right, today, meeting those kind of things.
Right. Well said. Thank you. Chandra, to you, a question from the audience. How do you really know that the investments you're making in AIOps is paying off? Is there a metric or matrices which can be used to measure? And second, how much of a human intervention is needed to infer the insights provided by such AI ML solutions? Just if you can respond to both these questions quickly, please.
Sure. First, the investment that is made on AIOps, we will start seeing that from two angles. One is in the reduction in the human manpower required to run a given IT operations. Bulk of the operations would be handled by the AIOps platform. And as the days goes by, you can even say up to 50 to 60% of the work can be handled by this platform, which means there is a reduction of workforce by 50%, and that's a direct savings on the IT OpEx cost. And this is how we can actually get the AIOps. Sorry, Bali, what was the second question?
Second question is, how much of a human intervention is needed for people to infer from the insights and others and take actions?
Actually, the objective of this platform, AIOps platform or any AIOps platform, is to make sure that we don't need to spend more and more time. Only when we want to get to know how the system is performing, you come to the system platform and then see what has happened. Otherwise, the human efforts are not required that much because the system takes care of that. As I said, as a response to the previous question, you can say about 50 to 60% of the current human efforts will go down. And it's not only reducing the man efforts, it's also improving the quality of service. It's not just reducing the manpower, reducing the incident. We are actually making sure that the service reliability goes up. That means services are running for more time with less and less interruptions, and the user experience also is consistent or improved. So the value of the service, the quality of the service that we provide is also getting improved with this AIOps platform.
Thanks, Chandra, for the clarification. Professor, I'm coming to the last. This is the last question of the call, and we'll wrap the call after this. You spoke about artificial general intelligence. There's a question directed saying, is artificial general intelligence bordering on singularity?
Oh, that is a very futurist question, and singularity will change definition depending on who you ask. No, I don't think so. I think there is the view of the strong AI, and then there is the weak AI. Both of these are hypotheses that you can kind of Google up and find out what they're talking about. I won't go into that, but I still think singularity, as people kind of refer to it, refers to strong AI, a notion of being indistinguishable from human being, a notion of conscience or a consciousness, not conscience. Consciousness being there in this living, breathing kind of agent. And that's where we kind of talk about singularity in some sense. And I think that's too far away for me to comment. But at the very least, even when you speak about AGI, you're talking definitely not at that level. You're talking at that level of doing way better than individual task-based learning. So concepts such as transfer learning, you learn something on one task, why can't I transfer the same insights to another task? And some kind of primal building blocks, right? So there's so much of unsupervised learning that a child does before it starts actually learning. So it learns the physics of movement before it tries to actually cycle, right? So that kind of learning, and the physics of movement, by the way, helps whether you're going to cycle or ski or walk. It didn't matter, right? So whereas traditional, AI has been very task-oriented, learn to cycle, learn to walk, learn to ski separately. So AGI is very much at the level of saying something as simple as, hey, if you want to do tasks of mobility, why don't you learn physics first, physics of movement? So that is the same principle that AGI is bringing. Perhaps there is an interpretation that is one of singularity, but not one that I meant.
Okay, understand. Thank you, Professor, for the clarification. Audience, thank you for your questions. We are at the end of the webinar. I would like to sincerely thank the audience for participating and coming up with these questions. I hope it was useful and insightful for you in your decision making and your understanding. Professor Nandan, Mr. Mulay, and Chandra, thank you so much for taking the time out of your busy schedule. Share your thoughts and views on this very interesting topic of service reliability and how AIOps importance in providing service reliability, service assurance, and end user experience. Thank you very much. Good evening and good morning, wherever you are. Thank you for joining the webinar. Look forward to another webinar again pretty soon. Thank you and bye for now.
Thank you. Thank you all.
Thank you, Balaji. Thank you, Chandra. Thank you, Mulay.
Thank you, everybody. Thank you, Professor. Thank you, Chandra.
Thank you. Good night.